Okay, Algebra 2, I'm home today, but I'm going to go through section 2-4 notes with you. You should have one of these, and then there's going to be a homework worksheet. So make sure you get that from, I think, Angie's. You're going to be your sub. So another thing that I will say to you is 2-4 is the middle of the chapter. So tomorrow, make sure you have your notes with you. Bring those with you because we'll have a mid-chapter quiz tomorrow. So kind of get that announcement out of the way so I make sure I tell you that. All right, 2-4. Malia. Hey, Malia. You got to be quiet, honey. Okay, so 2-4. I'm going to start in this box. What they're going to do in section 2-4 is we're going to be sketching functions. They will tell you to start with whether it's a linear function. So these guys are going to be lines. Or, I'll say lines, or whether it's non-linear. So these are going to be like curvy kind of graphs, okay? So use those as kind of context clues to tell you. I think they do that on your homework assignment as well, whether it's linear or non-linear. That can kind of help you. But the graphs of these functions, they're going to give us some of these pieces of information here, okay? So I'm going to go through kind of what each one of those talks about, or what each one of those is. And the x-intercept, if they say that, that's going to be where it crosses the x-axis, okay? So if you don't already know that, these are x-intercepts right here, x, and these are going to be the y-intercepts here because they're intersecting the y-axis, okay? So x-intercepts, y-intercepts, that's what those guys are going to be. A function is positive versus a function being negative, okay? A lot of people mess that up and interchange positive with increasing. Positive does not mean the same thing as increasing. Positive means it's above the x-axis, okay? So let me do the different colors here. Positive, it's positive if it's going to be up here, okay? It's negative if your function is like below the x-axis. So this guy just means above the x-axis. Negative means below the x-axis. Increasing is a little bit different, okay? Increasing means he's going uphill from left to right. Decreasing means he's going downhill from left to right, okay? And then we talked yesterday about end behavior, okay? So that's that part where as x goes toward infinity, y is doing something. As x goes toward negative infinity, y is doing something, okay? And that will kind of tell you where basically where the arrows of the graph go, okay? So use the key feature to sketch a linear graph, okay? The y-intercept is -70. They're giving us here on this graph, they're giving us just the third quadrant. Malia, you're going to have to be quiet, babe. All right, y-intercept is -70. So I'm going to go 10, 20, 30, 40, 50, 60, 70. I'm going to go -70 here. I'm going to go by tens, but every two. So basically I'm going by fives. Every two spaces there is 10. Okay, so that's -70. And I'm going to put a dot there because that's the y-intercept, okay? It says the function is positive for x is less than -30. Okay, so I'm going to do -30, 1, 2, 3. And that means from this point and to the left. So everything to the left of this point is going to be above this line. Okay, so I'm going to undo that. Everything to the left of that point is going to be above that y-axis. Okay, so let's just keep that in mind. The function is decreasing for all values of x. Okay. And we kind of know that this is a line already. So if it's got to go through this point right here, and it's got to go through this point right here, let's just connect those dots, okay? And I'm going to try really hard to make this a straight line. Let's see if I can do it. There we go. Okay, and I'm going to do another line this way. There we go. Okay, so this is going to be my linear function. Let's see if it's consistent with all the other stuff. So we said x has to be less than -30 is where it's positive. So this little branch right here, he's above the x-axis on the left side of -30. Okay, I'll mark this as -30. Okay, the function is decreasing for all values of x. It's going downhill. And it says as x goes toward infinity, that means to the right. As it goes to the right, it should be an arrow. F of x is going toward negative infinity. Okay, that's this part down here. Oh, sakes. So as x goes toward the right, he's going downhill. As x goes toward the left, he's going toward positive infinity, which means he's going uphill, okay? So that's what my function looks like. It's consistent with all that information, and that's all that I have to do is just draw that, okay? Nonlinear functions, they're going to do stuff and say like extrema, so they'll say like maximum and minimum points or located at a certain spot. They also say it's symmetric. So do you remember when we talked about line symmetry? They'll say it's symmetric with respect to some line. So that means if, you know, here's my line and we have something that's doing like this, then it's doing that same thing on the other side. Okay. All right. Use the given key features to sketch a nonlinear graph. The first one says this: the y-intercept is -5. So we're going to go down and put a dot on -5. Okay. And that's where he is. The function is positive when x is less than -3. Okay. So we're going to go to -3, and I'm going to put a dot on -3. And when x is less than that, so when x is on the right side of -3, he's above the x-axis. So we've got something going on like that, okay? So he's going to start here, and when he's on the left side, he's going to go up that way, okay? All right, I'm going to erase that. We're gonna just keep that in mind. And when x is greater than 4, he's also above. So everything to the right of -4 is going to be above this x-axis as well, okay? All right, so the function has a minimum at 2, -6. So the low point, there's a really low point right there at 2, -6. The function is increasing when x is greater than 2. Okay, so my x-axis right here at 2, if I'm looking at 2 being that line, everything to the right of this line is going to be increasing. So it's going uphill. So I can kind of think about, don't write any of this down yet. I can kind of think about the line that joins those two is maybe doing something like that. That means everything to the right of 2 is going uphill, okay? So maybe let's just do that. Let's just connect these points. I think that's what's going to happen here, okay? And that's it. That's all the information they give us except the end behavior. Okay, we'll check that here in just a second. So I've got a couple other dots. Let's see what this thing looks like. I'm going to connect those guys. So he's doing this and something like that. Okay. Now I don't necessarily know that he doesn't have another, like maybe he does like another little whoop-de-doo here, right? Maybe he looks like that instead. I don't know how if there's any other humps there, but you know. So that could be another way of making this graph, right? All I know is that he goes through these points, and this guy is a minimum point, but he could have other little loops and stuff in there. So let's just draw them like that. You can add another loop in there if you want to. It doesn't really matter. It doesn't say that there's another one, but you know, with the information that we have given, if we put another loop in there, it's not incorrect. So let's check the end behavior. This says as x goes toward infinity, so as x goes to the right, he is going toward infinity, so he's going up. So as he's going to the right, he's going up. That's correct. As he's going to the left, that's what this guy is saying. He is going up as well. So up and up. So this is the graph of what that thing could look like, okay? And this is, again, a non-linear graph, okay? Let's go down to the next one. They're going to give us another, some more information. The function is continuous and symmetric. Continuous means there's no like breaks or anything in the graph, and we haven't really talked about things that are not continuous. So there's no breaks or anything in the graph, and it says it's symmetric. Okay, symmetric means that it's got the same thing on both sides of the line, so it's symmetric about the line x equals -1. So the line x equals -1 is this line right here. I'm going to put a dotted line there so that we know that that's kind of the symmetry line where he's the same on both sides. Okay, the function has a maximum at -1, 4. Okay, -1, 4 is this dot right here. That's the highest point. Okay, and then that's really all the information it gives to me, except as it goes to the right, it goes down, and as it goes to the left, it goes down. Okay, so I know it goes through this point right here that's a maximum, and it's just going down on either side, and it has to look the same on both sides. Okay, so I could just make this guy look like a parabola if I want to, and he could go down on both sides. Ugh, that doesn't really look very symmetric. Okay, now I could also, maybe I have him doing, I don't know, like an extra little hump here, right? Maybe he looks like that. Okay, because it doesn't say that there's not other stuff involved in there. But probably the easiest thing to do would just be to make him look like a parabola and make him down on both sides. You probably are getting frustrated with me always erasing. That's okay. So there, I'm going to make him look like that. That's kind of the easiest, most simplified graph that just contains everything with not any extra humps or bumps or anything like that. That's consistent with all of my information. And there we have it. Okay? All right, last thing, there's a lot of bullet points here. We're going to go through each one of these bullet points one by one, and we're talking about Jose's test track drive. So what's happening is he's driving this vehicle for approximately 5 minutes, maybe 6 minutes, and he's increasing speed and decreasing speed and going a constant speed and that type of thing. So we can see on this graph, and they're going to give us a story that kind of goes along with this, and we're going to put those points down. So Jose decides to go to a test track to drive a racing car. He drives the car for a little over 5 minutes. Okay, nothing really that we can graph with that. We just kind of know the background information behind this. It says the y-intercept. Jose starts driving at 0 miles per hour, right? He gets in the car and it's going 0 miles per hour. So I'm going to start at 0. Okay, and we've done that bullet point. Is it linear or nonlinear? The function that models the situation is nonlinear, okay? So even though we might have lines that are going on here, specifically, like there's not going to be one straight line because he's going to increase his speed, probably go that speed for a little while, and then decrease his speed and something like that. So we know that this graph is nonlinear. Not really anything that we can graph from there. Jose's maximum speed is 150 miles per hour, okay? So 150 is about right here on the graph, which he reaches 30 seconds after he starts driving. Okay, so on this x-axis, 30 seconds would be this guy right here. So 30 seconds after he starts driving, he is up at this point right here. He's up at 150. So I'm going to take my line and I'm going to connect him right there. He's going increasing speed until 30 seconds when he reaches 150 miles per hour. Okay, so that bullet point is done. Increasing. Jose's speed is increasing steadily for the first 30 seconds. We just graphed that, so that's an increasing part. That bullet point is done. Decreasing. At the 2-minute mark, Jose decreases his speed for 0.25 minutes, which is a quarter of a minute, which is really a fourth of a minute is actually 15 seconds. Okay, so he's decreasing his speed for 15 seconds, and he stays at 100 miles per hour for 2.75 minutes. Okay, there's a lot of stuff going on in this bullet point. So at the 2-minute mark, so what's he doing until he gets to the 2-minute mark? He's probably staying at 150 miles per hour. So I'm going to go and put a dot right here at the 2-minute mark, and he's going to stay at 150 for those 2 minutes. Okay, that line doesn't look very straight, but yeah, make a straight line until we get to 2 minutes. And so that was at the 2-minute mark, he decreases his speed for 15 seconds to 100 miles per hour. So 15 seconds. If I'm looking at the 2-minute mark is where I'm at right now. The 3-minute mark is here. This would be 2 minutes and 30 seconds. 2 minutes and 15 seconds would be right here. It's like halfway through, and I am down at 100. Like halfway through there. Okay, so 15 seconds is just half of a block, and I'm going from here down there to 15 seconds, or in 15 seconds. Okay, he stays at 100 miles per hour for 2.75 minutes. Okay, so 2.75 minutes. Right now we're at 2.25 minutes. This is where we're at, 2.25 minutes. So if I'm going to stay at 100 miles per hour for another 2.75 minutes, that will get me to the 5-minute mark. Okay, so at the 5-minute mark, I'm still going 100 miles per hour, and then I'm going to do something different. Okay, so that will stay like that. Okay, at the 5-minute mark, he again decreases his speed for 30 seconds until he reaches a stop. So at the 5 minute and 30 second, he's going to be back down to 0 here. Okay, so we're going from here straight down. Okay, that's him decreasing his speed until he reaches a stop. So we've included everything in that bullet point. The last thing is the end behavior. The graph has no end behavior. This one's kind of a weird one. He has no end behavior, okay? End behavior happens when you have arrows going on, right? It's like talking about the ends of the graph. Well, here, the graphs don't have arrows on the bottom because they do, in fact, end, right? He is starting at 0, stopping at 0. He doesn't go into the negatives. So it doesn't have an end behavior because it ends. So the behavior at the ends of the graph don't occur because there is an end to the graph. So the graph has no end behavior. He starts at 0 and he stops at 0, and this is what the graph of his function looks like. So if you were to, give us this graph, we could go ahead and kind of make a story problem that goes along with that. Just go through each bullet point one thing at a time. Don't try to do everything all at once. Go through each bullet point kind of like we did, and just plot the things that you know and plot the things that that it tells you to, step by step. And yeah, that graph came out kind of nice. Okay, on your homework assignment, there is like 5 problems on the one side and like 6 problems on the other side. Go ahead and do all on both sides. These graphs don't take too terribly long. Make sure you're keeping in mind whether they're nonlinear or whether they're linear graphs. Okay, that can really help you. In a linear graph, we didn't even get like halfway through the graph and we kind of knew what the line looked like. Okay, so those ones are going to be a little bit easier to do. But pay attention to those, and this should be a pretty quick and easy assignment for you. Okay, mid-chapter quiz tomorrow. Be ready for that. Make sure you have your notes with you. Everybody say bye, Kason, because he's yapping. He needs to be fed. Goodbye.